In this series of videos, I want to discuss resolution and how that affects a resource-oriented computing system. This is NetKernel, and I'm going to use some demos that you can actually install into NetKernel and follow along as I explain the different patterns that can be used for resolution approaches. So starting on the homepage of NetKernel, I just want to give you a little bit of background on ROC just to frame up where resolution fits into the picture. So go to the documentation and the resource-oriented computing guide. We see on the first page of the book a diagram, and this diagram is basically a summary of the whole resource-oriented computing abstraction. What I'm going to do is I'm going to describe it from the point of view of something that's familiar to you, which is the web and the web architecture, and then I'm going to show how ROC fits in and where ROC generalizes some of the features of the diagram. So imagine for a moment this is a web browser, and we've constructed a URL, a request for a web resource, and the web browser, although we don't really feel it, lives in an address space, and this address space is the set of all resources that can be addressed by the HTTP protocol. And when a request is made by a browser, what it does is it consults with the DNS to resolve a physical server, an endpoint, and then it issues the request for the URL to that physical server. The physical server then looks at the resource identifier and determines how it's going to compute a representation of the state of that resource and return it to the requester. And in the web, the relationship between the browser and the server is effectively backed by decoupled by DNS, and the requester is responsible for resolving the physical IP address of the server, although obviously network intermediaries can have a role as well. What I want to show you is that in resource-oriented computing, we've taken the idea of this address space and said, well, there can be as many spaces as is convenient for our architecture. And when we want to issue a request for a piece of information, then we can actually explicitly delegate the resolution to a combination of the space and the sets of providers of information in those spaces, and we allow the resolution to have a rich flexibility that allows us to create powerful systems. But effectively, the same architecture as the web is now brought inside to the software system. We have software functions that construct resource identifiers as requests. They issue those requests into the space in which they reside. The request is resolved to some physical software component. The software component looks at the request, determines how it's going to compute a value for that request, and returns a representation, some state, back to the originating requester. If we look at the other diagram in the request processing, in the logical section of the request processing, there's a diagram that talks about resolution. And this is one of the more subtle but powerful aspects of the resource-oriented model, in that it's two-phase. We have a phase where we resolve, where we issue a request, and we allow the space and the combination of endpoints it contains to determine which software, physical software endpoint we actually want to execute. And then once we've determined which one we want to execute, the request gets issued to that endpoint for execution, and the endpoint then receives that request. And what I want to talk about and show you is a set of demos that show the richness and power of this delegation of resolution and how we can exploit that in our own systems. So the best way to understand this is to start with a demo, and what I'm going to do is go to the Space Explorer. I'm going to look at all my modules, and I'm going to look for the resolution demo, which you can have installed as well. And if I click on module details, what I see is a list of address spaces. As I said, ROC allows you to have as many spaces as you like. Each space is just its own self-contained micro World Wide Web, if you like. So let's look at this single space here and just see a diagram for it. And what we have is an address space, and we see it contains one endpoint, and it's creatively called accessor1. So what I want to do is I'm going to actually go and look at how this space is implemented and look at the source code for the module. So over here I've got a module XML, and we see its NetKernel demo resolution is the module, and it's my demos. And inside it contains a root space for part 1, which is this tutorial we're doing. And we see that the this space contains one endpoint. It's an accessor declaration, and the accessor will physically fire up an instance of the class resources.accessor1. And if we go and look at, if I go and find my, should have prepared this, shouldn't I? There it is. If I go and look at the source and hit accessor1, we see that it's a standard accessor, and it implements the source verb, so it's overriding on source, and it receives a request context, and whenever it's requested for source, it just returns the string active :1 to show that you've hit this endpoint. It's a dumb endpoint. So that's what this endpoint does, and we see that it's addressable with the identifier in its grammar active :1. So this address space contains the resource active :1, and if we make a request for it, it'll fire up this physical endpoint and return as active :1 as a string. So the interesting question for us is can we look at the resolution in this address space? Can we probe this address space to prove to ourselves that this really does contain this identifier? Does this space provide consistently that resource that we want to look at? And the way we can do that is we can go to the NetKernel tools. I'm just going to open another tab for that. And there's a tool in the developer tab called Request Resolution Trace Tool. And this allows us to inject requests to any space in the system that we want to probe. So here I've got my demo resolution module, and you see we've got a list of spaces that we can probe. And I'm going to just look at the first space in there, which is the one I just looked at, part 1 endpoint. Now what we know is that we think that this space contains the resource active :1. So if I try and resolve that request by hitting the resolve button, what we see is a report that says, yep, there is a physical endpoint called accessor1, and it's got a logical identifier of ID of this part 1 accessor1. We resolved it in the address space part 1 endpoint, and if we open up this little diagram, this little drop down list here, we show how this endpoint was discovered. What was the flow? Remember this diagram up here. What was the process by which the resolution occurred? The requester made the request. In this case we were actually probing from outside, but an endpoint in this space would have issued a request. How was it determined that the endpoint that we hit was resolved in the address space? And that's what this little diagram, this little list shows us here. It shows that we started looking in the part 1 endpoint space, and we found a match on the physical endpoint accessor1. Okay, so if now I try and actually make that request, so I actually physically executed that request, then the endpoint fired up, on source method was called, and active1 was returned to me. So if I try a different verb, so for example sync, remember my endpoint implementation only overrides and implements the source verb. It doesn't implement on sync, on delete, on exists, on new, all the other verbs of ROC. So if I try and issue a sync request to that verb, or try and resolve a sync request to that endpoint, what I get is no physical endpoint, no logical endpoint, no resolve scope, and we find that the resolution trace says it started in this space. There was no match on accessor 1. So it tried, it knocked on the door of accessor 1 and says, do you want this request? And accessor 1 said, no, it doesn't match. You didn't have the correct verb to satisfy their request. And eventually no match was found, and so the resolution failed. And if we now try and actually execute that request, then what we find is unsupported verb. Verb sync not supported by resources accessor 1. So we couldn't make the request. It wouldn't happen for us. Okay, we're going to go through many of the patterns, of the sort of orthogonal patterns that you can use to set up address spaces and use resolution to create powerful patterns. But this has just been a basic first step introduction.